Okay, what did you guys get for number 1?
30 plus the integral of root of 3 times 3
Nice.
dt equals t of 12.
Is that what you said? Okay, good. Now I did hear some of you put in the 1 minus 3 blah blah blah, and that's fine too. Everybody make sure you did a dt. All right, for 2, it is more difficult, but it's okay. No, we didn't have to, but we could do, it would be p of 12. Yeah. All right, and then for number 2. So what information are we given? Like our initial amount? Or we have an amount of 60. Now, is this water is it going in or out? It's out, so we subtract. Now, this is where I think it gets kind of tricky. At what time is there 60 gallons? 10. So 10 has to be at the bottom. I know that seems weird, but it is the lower limit. The same thing on the first one. This was, we had 30 gallons at time 0. So 0 is your lower limit. So 60 gallons at time 10. So 10 is the lower. What do we want to find? Like what time do we want to find? 0. Good. And then this one, we would need to go ahead and do the square root of t plus 1. And don't forget your dt.
And that equals.
We doesn't have to equal anything.
But like,
We're just writing, we're given just the rate of change. We're not given what the function is called, so we can't really say on that one. Or the next one, we can't really say what it is. Okay, so what'd y'all get for 3? 220 plus
the integral
minus from 10 to 15, and then your function. Okay, 4 was also, oh, thank you. 4 was also a little tricky also. So we're given the rate at which people are entering and the rate at which people are leaving the fair. And we have to figure out how many people should be at the fair 3 hours after the fair opened. So what'd y'all start with? 200. Are we adding or subtracting the integral? We're adding. What's our lower limit? 1. What's our upper limit? Okay. What's our function?
60t plus 60.
You don't take it.
What did you do? Is it just E of t?
Why don't you do the e prime of t?
E of t is a rate already. Both of these are rates.
Yeah, we put in the numbers for it.
So 30.
What do you do with E of t and L of t to figure out how many people are in the fair? Subtract, okay. This is all I did. Now, if you put in the numbers, it would be 30t squared plus 4t plus 3 dt, right? Okay. Okay, so I want you guys to turn to page 2 and look at this table. We're going to take a second and decide if these problems on the previous page need to be done by a calculator or if we can find the integral by hand. So I'm going to let y'all get that. I'm going to rewrite a couple of these so you can make that decision a little bit better. But you guys be on the second page. You don't have to flip back and forth. Page 2, yeah. Okay, so number 1. Do you guys think you can do number 1 by hand, or do we need to use a calculator?
Calculator.
So put a check in the calculator part of number 1. What's messing it up by doing it by hand? Well, we can do the antiderivative of e to the t, but the antiderivative of e to the square root of t, we would have to have a little extra stuff multiplied because we'd have to find the derivative of the square root of t. It's not just 1. So that one is calculator for sure. What about number 2? We can do it by hand because the derivative, what's the derivative of t plus 1? 1. So we can definitely do that one by hand. What about number 3? Calculator, why?
There's an ln.
We can do the antiderivative of ln.
This is the x squared.
X squared. The derivative of x squared is 2x. We would need to have a 2x somewhere, or at least an x somewhere multiplied. All right, what about number 4? Calculator, or can we do this by hand? We can do that one by hand. Okay. So you guys can see all my calculators have gone to boot camp. So we're not going to do the calculator problems. We're only going to do one of the hand problems. And tomorrow, hopefully, I'll have my calculators back by the end of the day. I think you all remember how to do the antiderivative in the calculator, right? The alpha window, yeah. Okay. Let's do number 4 by hand. So let's just write the problem in here. So I went ahead and subtracted them a second ago. And got 30t squared plus 4t plus 3 dt. Okay, so when I take the antiderivative, I don't write the symbol anymore. What do I write if I have to plug in numbers? The bracket, good. All right, so you guys take a second and find the antiderivative of that. Find what function has that as a derivative. Okay, so we're adding 1 to the powers and we're dividing by our new power. Okay, so now we're going to use the fundamental theorem of calculus. So we're going to plug in 3 and 1. Which are we going to plug in first? 3. So, oh, I wrote that wrong. Did y'all see that? It should be 2t squared. Right, and then we're going to subtract what we get when we plug in 1. Now, plugging in 1 is easy. You just add the coefficients together. All right, and I know if you guys were given enough time, you could do this. It would take some calculating, but it's fine. I'm just going to tell you what you're going to get is 482. And then I want you to tell me what that means. What is 482? This was the fair problem. So there's 482 people.
We don't have to put plus in numbers.
Not whenever you do the definite integral. So 482 people at the fair when? Good job. 3 hours after it opens. Okay. All right, so now we're going to do some matching problems, and I worked through these before, and I did it both ways. Like at first I started with the integral and tried to find what it meant, and then to me it ended up being easier if I started with the words and went back to the integral. So all of these integrals are about the same situation, which is a pipeline company manufactures pipe that sells for $100 per meter. That's going to come back to be important in a second. The cost of manufacturing a portion of the pipe varies with its distance from the beginning of the pipe. The company reports that the cost to produce a portion of the pipe that is X meters from the beginning of the pipe is C of X dollars per meter. And then they do tell you what profit means. And I think you guys know, but that's okay. Profit is defined as the difference between the amount of money received by the company for selling the pipe and the amount it costs to manufacture the pipe. Okay. So now, I'm going to start with A. So A says we want to find an integral that represents the difference in sales price in dollars between 100 meters of pipe and 50 meters of pipe. So what was the sales price? Like where was that? It was $100 per meter. So we do need to make sure whichever one we pick has that in it. And then we are talking about the difference in 100 meters and 50 meters. So those are going to be your upper and lower limits. So what do y'all think? Which integral?
4.
Well, 4 doesn't have the 100. I think 7 is more about profit, so it's going to be 6. We're only talking about the sell. We're not talking about the cost on this one. All right, for B, the cost, we are talking, so we're going to definitely have a C on this one. The cost in dollars of manufacturing 125 meters of pipe. Yes. Okay, for me, it's kind of easier to pick out which ones are going to be average. So we have 3 different average ones. Which ones do you guys think are the average value ones? 2, 3, 4, 2, 3, and 5. Okay, so C is the average profit in dollars per meter made on the sale of 125 meters of pipe. Which one of those do you guys think that is? 2. So we're taking the sales price, subtracting the cost, and then finding the average of 125. Okay, for D, the difference in cost in in dollars of manufacturing 100 meters of pipe and 50 meters of pipe. The difference in cost is going to be 7. I'm sorry, 4. 7 is still talking about profit. 4 is only talking about cost. All right. The average rate of change in dollars per meter in the cost. Let me start over. The average rate of change in dollars per meter in the cost per meter of pipe. Okay, this is the only one that has a prime, which is going to be rate of change, so that's going to be E. All right, the difference in the profit between selling 100 and selling 50, that's 7. All right, and the average difference in cost per meter in dollars per meter, this is worded hard. All right, that's definitely going to be 5. It's the only one left, but do you guys see why? It's the average, and we're talking about a difference of 50 meters, so that's why that's 1 over 50 out there. Okay, do you guys want to try the next one on your own?
Not really,
I'll get you started. All right, a cup of boiling water is removed from a microwave and set on the counter to cool. The initial temperature of the water is 100 degrees Celsius, so that's important. The temperature of the water, T, is measured in degrees Celsius. And then is a function of time, T, which is measured in minutes. All right, so our information is a little different here, and they're asking you to find some different things like T of 4 and T prime of 4 that are kind of review problems. So A says, an equation that can be solved to find K, the time in minutes when the average temperature of the water is 85 degrees Celsius. So we definitely want one with a K. There's 2 equations that have K, 7 and 8. Which one of those is going to be the average temperature? Oh, wait.
Oh, I know, 8. Eight is the average one, right?
Okay, what's the difference between A and H?
Huh?
Look at H.
H.
The time interval, so it's included. Oh, wait, no.
Are you asking us because you don't know, or?
No, I want you to look at it.
No,
They look identical.
when is the position play?
Which one would use 100?
H.
I'm pretty sure it's going to be 7.
A.
Yep, so this is A.
Why?
And this is H. Okay, for one, I wish it would have said the average rate because it has that T prime of T. So an equation that can be solved to find K, the time in minutes when the average temperature of the water. An equation that can be solved to determine K when the average temperature of the water over the time. I think they're the same. Do the rest of them. It's fine.
So when it's talking about temperature, you don't use a prime.
We're talking about temperature. You don't use it.
Correct.
The function is temperature.
So how would you know when to use a prime and not to?
Okay, are you talking about number 1 or are you talking about the integrals that have a prime? Okay, so to do the integrals that have a prime, if you're wanting to find a final amount, like if you're just talking about temperature, it would need to have a prime.
Final amount. Okay.
Yes, for sure. For the integral. Now, there's a difference between this one and this one. Now, when you're doing average, this right here means average temperature. Number 3. So when you're doing the average formula, whatever is here, the T of T, that's what you're finding the average of. This one was more difficult than I thought. You guys do the rest of them on your own. You shouldn't be on your phone. Are y'all done? What do y'all think about 1? B. That's an old problem. All right, what about 2? One more time? G, yes. What about 3? 4? F. 5? 6? Good. And these last 2, I'm still not 100%. I can tell when I did it the first time, I did say 8 was A. And then I changed it, and now I don't remember why. So, sorry. They are almost worded identical, so that's weird.
It has over the time interval from
They're both over the time interval. Oh, yes. I think that is what the difference is. Even though they both do have that same time interval.
So what's the difference?
This is the average temperature. The other one is the average temperature too.
Okay, changing that gives by product A. Looking yourself to determine the time.
They're both the time K.
Oh, the time.
And maybe they would both work out to be the same K.